Hi, welcome to part 4 of our lecture on the solar system. In this last part of this chapter, we will be looking at so-called space debris, which includes asteroids, shown here, meteorites, here's an example of one here, and comets. This material is leftover debris from the origin of our solar system, and it's important from a scientific standpoint because it's evidence of the solar nebula theory, which explains the formation of our solar system 4.5 billion years ago. Let's start by talking about the asteroids. Asteroids are small rocky bodies orbiting the sun. Their sizes range from pebbles up to 600 miles in diameter. Their surfaces are marked with craters, and they're made mostly of rock and metal. Here are pictures, actual images taken of 4 asteroids, and these were taken by spacecraft that basically did a rendezvous with the asteroids to study them. So you get a good sense of what these asteroids look like. Notice they're typically not round, they're not large enough to have created and pulled themselves into a spherical shape, except for there is one asteroid that is almost a sphere, but most of them look more like this. They're sort of potato-shaped objects. So where are the asteroids? Well, most of them are found inside of a region called the asteroid belt. The asteroid belt is a band of asteroids between the orbits of Mars and Jupiter. So take a look at this model of our solar system. The sun is in the center, and here we have the inner planets of the solar system: Mercury, Venus, here's Earth in its orbit, and this is Mars's orbit. Now, out here is the next planet, Jupiter. But notice in between the orbits of Mars and Jupiter is this region right here. This is the main belt of the asteroid. And it turns out that these asteroids are what's left of a planet that failed to form. So it's thought that the influence of Jupiter here disrupted the formation of this planet, and what's left here is this trail of debris, of rocky debris, and these are the asteroids. Let's now talk about meteors and meteorites. So a meteor is a small space rock that collides with the Earth's upper atmosphere. It can collide with speeds anywhere from 20,000 to 50,000 miles per hour and will produce a visible light streak in the sky some 50 miles up. Even a grain of sand-sized meteor particle will be visible, and we sometimes call them a shooting star or a falling star. Here's a picture of one here, but of course these have nothing to do with stars. They are just little bits of debris that slam into our atmosphere and burn up due to the friction with our atmosphere. Sometimes the meteors are large enough that they actually survive the plunge through the atmosphere and hit the surface of the Earth. This is an example of what is called a meteorite. So that's a meteor that doesn't completely burn up and it strikes the ground. So what are these meteorites and where do they come from? Well, they're typically fragments of asteroids, and they're made of iron and or rock. Occasionally, very large meteorites strike the Earth. This is a couple examples shown in museums of these are basically, you can think of these meteorites as small asteroids or fragments of larger asteroids. In the year 2013, there was a meteor that struck the Earth over the skies of Russia. And this meteor was approximately 15 meters in diameter, and it had an estimated mass of 7,000 tons, but it was too small to be detected ahead of time, so it completely surprised us when it arrived. It entered the atmosphere at 40,000 miles per hour, and it created an airburst or an explosion 15 miles above the surface of the Earth, and that released the same energy as 20 atomic bombs. There was a shock wave from this meteor meteor that broke windows and injured 1,000 people. The meteor was captured by several different people accidentally. For example, they had cameras on their dashboards of their vehicles and were able to record the fireball in the sky. And this is the trail that was left by the meteor. And here's a frozen lake in Russia where a portion of the meteor apparently struck and melted through the ice into the lake. Meteors often occur in what are called showers. And a meteor shower is a predictable occurrence that happens every year. You can look up when these meteor showers occur. This table here shows a list of some of the major meteor showers. There are more than are shown here, but these are the best ones. One of the most popular ones is the Perseid meteor shower, and the name gets its name from the constellation where the meteors appear to be coming from in the sky. But basically the Earth is moving into the swarm of meteors, and we'll talk about their origin shortly in the next slide. But the Perseid meteor shower peaks on August 12th every summer, and you can see 40 or sometimes even more meteors per hour. If you're away from city lights, if you go out camping in the desert or in the mountains, and if there's no moon in the sky, it can be a very entertaining and fun thing to see. Now, meteor showers have a different origin than the meteorites that I showed you previously. Meteor showers actually come from comets, not asteroids. And so the origin of a meteor shower is debris particles orbiting in the path of a comet. And the comet may not even exist anymore. It may just be the debris left over from the comet. So the way this works, look at this diagram here. Here's our sun in the center of the solar system, and this is the Earth here. So the Earth is going to orbit around in this roughly circular path here. Now, this is the orbit of a comet that left a trail of particles. And we'll talk about comets shortly in this chapter. You'll get a little more information on what a comet is. But this comet dust basically is left in this path here. And if the Earth just so happens to pass through this trail of comet debris, it will produce a meteor shower, and we'll see many meteors. Now, notice that this orbit of the Earth is going to go around, and it's going to come back, and the next year it will pass through the same position. So that's why the meteor showers occur annually. They happen basically on the same date every year, year after year. One of the scientific advantages of studying the debris that's left in our solar system is it can provide us with the most accurate age of the solar system. So according to the solar nebula theory, the sun and the planet should have about the same age. And we know that the sun is about 4 to 5 billion years old according to theoretical models. And we'll study how stars evolve and age in the next chapter. But from physical evidence, the ages of rocks can be measured through radioactive dating. So remember, we talked about this process in the previous chapter on the nucleus and nuclear physics. By looking at the ratio of isotopes in a sample, scientists or geologists can determine when that rock solidified and formed. And so by measuring and dating rocks on the Earth, the Moon, Martian rock samples, and also meteorites, they all suggest that the solar system formed about 4.5 billion years ago. And of course, this is a major piece of physical evidence for the solar nebula theory, which explains the formation of our solar system. Let's now turn to comets. This is a picture of a comet that I took back in 1997. This was a spectacularly bright comet called Hale-Bopp, and this was in the days before the digital cameras were available. So I actually took this using a Pentax 35mm film camera with a telephoto lens. And I took it up on Palmer Mountain, and this comet looked spectacular. You could see it very easily with the unaided eye. You didn't need binoculars or a telescope. You could even see it, from your driving your car down the freeway. I remember looking out the window of the car and I could see it in the sky. And it was around for probably a couple weeks. It was visible. One of the things about comets is that throughout history, comets have sometimes been associated with impending death, disasters, or plagues. And there was a horrible and gruesome story when Comet Hale-Bopp arrived in 1997. There was a mass suicide that took place right here in San Diego County in Rancho Santa Fe. They discovered 39 bodies in a mansion in Rancho Santa Fe, and all the deceased were members of a cult called Heaven's Gate. And the leader of the cult was this crazy guy here, and he convinced the followers of his cult that a UFO was flying behind Comet Hale-Bopp and was waiting to basically collect everyone's souls. So these people all committed suicide simultaneously. So this is kind of a modern story of what superstition and lack of knowledge, lack of scientific knowledge can do. So let's put away the ignorance and let's learn scientifically about what comets really are. So a comet contains an icy nucleus, and comets are kind of known for their beautiful tails, and we'll talk about that shortly. But the tail is coming from the body of the comet in here, or the nucleus. This is an actual photograph of a comet's nucleus, and they can be anywhere from a few miles to as much as 50 or 60 miles in diameter, up to 100 kilometers. And the nucleus contains rock, dust, ice. And when we say ice, by the way, that's frozen water, frozen carbon dioxide, frozen ammonia, and other chemicals as well, as we'll talk about shortly. One way to describe a comet is a dirty snowball or an icy mud ball. That's kind of an accurate description of what the nucleus of a comet looks like and behaves like. As the comet gets near the sun, the ices melt and evaporate, and they're blown into space by the solar wind pressure, and this forms the tail of a comet. One of the interesting things about a comet tail is that it always points away from the sun. So we see as the comet approaches, here's the sun, this is the comet's orbit here. As the comet approaches the sun, you can see the tail is trailing behind the comet, like we would kind of suspect. But look what happens when the comet goes around the sun. The tail whips around, and over here, the comet is moving in this direction. The tail is actually leading the comet, not trailing behind it. This is a picture of another comet that I took. This was back in 2006, and this was a more typical comet. Most of the comets that arrive and go around the sun are too dim to be seen with the naked eye, and so you need either binoculars or usually a more powerful telescope to actually see them. And this is an example of one. This comet, which has the name Schwarzmann-Watchman, was seen back in 2006, and I took an image of it using my digital camera through my 18-inch telescope, and this was taken up on Mount Laguna. So here again, this is the head of the comet here, and you can see the tail coming up there. There have been several interesting missions to explore the nature of comets. One of them was called Deep Impact, and this was a NASA spacecraft that actually shot a large projectile. It was an 800-pound impactor, basically like a giant bullet or cannonball that smashed into the comet at 23,000 miles per hour. It left a crater in the comet the size of a football field, and the comet material you can see was blasted into space, and it was collected by the spacecraft and analyzed. This is a close-up picture of the comet taken before the impact, and you can actually see some regions of frozen water ice on the surface of the comet. So what this mission found was silicates such as sand and other minerals like clay and carbonates or limestone. Also, some more interesting things like aromatic hydrocarbons, which are organic molecules. It found water ice and frozen carbon dioxide or dry ice, and it found some sort of semi-precious minerals such as green olivine and also iron minerals. So this is NASA's recipe here for comet soup. If you wanted to make a comet, here's all the stuff you would need. This is ice here, this is dry ice, and here are some of those minerals that were found inside the comet. Another interesting mission that we were able to learn quite a bit about comets was called Stardust, and this was another NASA mission. This Stardust mission flew by this comet here called Wild 2. This is a nice close-up image showing what the head of the comet, the nucleus of the comet, looked like. Basically, this mission collected samples of comet dust, and then the spacecraft returned to Earth. It sort of crash-landed out in the desert, and they were able to analyze the comet dust that was being released by this comet. One of the most interesting things that found by far was the amino acid glycine, which is shown here. Glycine is an amino acid which is a building block of protein and is a building block of life. So this kind of leads to an interesting thought that some of the raw materials for life itself on Earth may have been delivered from comets extraterrestrially. This was another comet mission called Rosetta. It went into orbit around the comet, and it actually released a lander that landed down on the surface of the comet. So this is what the comet looked like from a little bit farther away. It was about 3 miles in diameter. You can see it's sort of an irregularly shaped object here. And here is a much closer look at the surface of the comet. And this picture here is the first ever photograph taken from the surface of a comet by the Philae lander. You can actually see part of the lander leg here in the picture. So this is, you're seeing actually this lander touched down and landed on the surface of this comet and collected data and information. So where do comets come from? Well, they actually have two origins. There is the Kuiper Belt, which we studied in the last part of this video. Remember, the Kuiper Belt is a region of the solar system just outside of the orbit of Neptune. But there's another structure of our solar system that is even farther out, and that is called the Oort cloud. So the Oort cloud is a spherical cloud that contains, we think, trillions of icy bodies. And you can see the size of the Oort cloud. It's this giant sphere that surrounds our solar system. It's something like 3 light years in diameter. And occasionally, these icy objects in the Oort cloud become dislodged in their orbits, basically, and approach and come around the sun. And that's what creates a comet. So this is kind of a neat diagram here that really shows the entire structure of our solar system, from, with the sun in the center, the inner planets, the outer planets, the Kuiper Belt here, which is sort of, remember, a disc shape, a band of debris around the outer planets. And then we have this spherical cloud that surrounds the whole solar system, kind of like a big bubble. And it contains, we think, trillions of icy comets. Over the history of the Earth has been bombarded and impacted by comets and asteroids. Certainly this was much more common during the early stages of Earth's formation, especially during the first billion years or so. There was a period of heavy bombardment, it's called. But these bombardments have left their scars on Earth, and in fact there are still over 150 impact craters that are found on the Earth. Most of these craters have eroded away, and it's very difficult to see them today, but there are some examples that are still very prevalent and easy to notice. For example, the famous Barringer crater near Flagstaff, Arizona, is a tourist attraction, and you can go visit it. It's the result of an iron meteorite about the size of a football field that landed about 50,000 years ago, and the energy was equivalent to a 3 megaton nuclear bomb explosion. So it left this big crater here that can be still seen. This is a fairly recent event in geologic time, so the crater is still showing without much erosion. There's another famous crater called the Chicxulub crater. This is in Mexico at the tip of the Yucatan Peninsula. It's shown right here. It was actually discovered using something called a gravity map. The crater is filled in due to limestone deposits, but it happened 65 million years ago. They were able to determine that by dating the sediments and the rocks that make up the crater. Now, the interesting thing about this Chicxulub crater is, first of all, they found the crater, and they determined that it happened 65 million years ago when the impact occurred. There's also traces of iridium everywhere around the world at 65 million years old. In other words, the sediments in the layers of rocks on all the continents show a presence of iridium that was deposited 65 million years ago. So it's believed to have come from this comet or asteroid that hit Chicxulub. And iridium is, by the way, it's common in meteorites, but it's very rare in the Earth's crust, so that's why they think it came from space. Also, near the crater, there are melted or shocked quartz samples and tektites, which are melted glassy minerals that formed during the impact. But maybe the most compelling evidence for this Chicxulub impact is in the fossil record. The fossil record tells us that dinosaurs and about 75% of all the species on Earth had a mass extinction event that occurred 65 million years ago. So what killed the dinosaurs? Well, our best bet right now is that it was the result of this major impact which happened here in Chicxulub, and this impact would have caused a global catastrophe. The clouds and the dust that would have been kicked up from this impact would have caused a prolonged winter that might have lasted years or even decades without sunlight being able to penetrate, creating sort of a winter environment across the Earth. This would have resulted in plant life loss, and a lot of the larger animal species like the dinosaurs disappeared. Of course, there's another explanation for why the dinosaurs went extinct, and that's shown in this clever cartoon here. Okay, our last slide here for our chapter on the solar system is just a summary of all the evidence for the solar nebula theory that explains the formation of our solar system. And so this is just sort of a summary of the data that we've talked about in these last 4 videos. So I won't go through it in great detail, but the shape of our solar system suggests that it formed from a disk-like shape of gas, which is, that's basically the solar nebula theory, explains that disk shape. Dust disks and planet formation observed around newly forming stars other than our sun shows that the solar nebula theory is happening elsewhere, and it's very commonplace. We've confirmed more than 4,000 extrasolar planets, which again is evidence for the solar nebula theory for planet formation. And the direction of planet orbits and rotation suggests that all of them came from a common rotating disk of gas and dust. The difference between the planets can be explained, and we didn't get into this, the details of this in this course, but the terrestrial planets and the Jovian planets geology can be explained by the solar nebula theory. The missing planet at the location of the asteroid belt between Mars and Jupiter suggests that another planet was trying to form there. And then we saw the space debris. Comets and asteroids and meteoroids are the last debris left behind by the solar nebula. And again, the age of the solar system is determined from this space debris to be 4.5 billion years ago. So we finished our study of the solar system in this chapter. Next chapter, we're going to move on and look at stars, and including our own sun. I'll see you then.